Unit 10, Lesson 1. This is going to be the last unit for this year of my geometry class. So we're nearing the finish line. It is currently April, and we're going to kind of round out this month and tuck in a little bit of May and then be out. So this is it for this, at least this year. May get farther in the future, who knows? But we are going to dive into some circles. So this lesson, or excuse me, this unit, we return to high school. we're done with going back to 8th grade and all of those things. We're going to learn some equations and stuff relating to circles. Circles are super cool. This particular lesson is actually going to be really easy because it's going to be entirely review, basically. And so we're, excuse me. Yeah, and we're actually not going to even do any examples. We're just going to talk about concepts and get you a little vocabulary, get you, remind you of what the formula is, remind you what pi is, all the things, maybe even get a little philosophical. Let's dive in. So, special segments in circles. So, there are 3 types of special segments in circles. There are chords, diameters, and radii. Radii is the plural of radius. Okay, so it's worth noting that actually a diameter is also a chord. It is a specific kind of chord. So what is a chord? So a chord is a segment which touches two points on a circle. Okay, so AB is a chord. DE is technically also a chord. It's just a specialized chord, and it is called a diameter. So a diameter. Now, these I'm not going to write definitions for because you have them in your brain. I already know you do. I know you do, because if anything is covered well, typically in a lot of middle school maths, it is basic geometry like this. And so you know what a diameter is, you know what a radius is. If I was to go and ask you, what is the formula for the circumference of a circle, you could tell me. I'm almost certain of it. We're going to remind you of all those formulas and all that stuff, so don't stress if you're like, but wait, I don't actually remember that. So a diameter is a chord which cuts a triangle in, it's not a triangle. We do so much with triangles in this class. It cuts a circle in half. So it goes right through the center. This C is the center. The radius is half of a diameter. It goes from the center of the circle. It's a segment that goes from the center of the circle to the edge of the circle. So if we want to calculate the radius from the diameter and vice versa, you probably already know this. That if we have the diameter and we want to find the radius, we just take the diameter, divide it by 2, and we get the radius. If we have the radius and we want to get the diameter, we take the radius, multiply it by 2, and we get the diameter. This is all stuff that you probably know. The diameter is twice the length of a radius. A radius is half the length of a diameter, right? Easy, easy peasy, right? Let's talk about something else. So another vocabulary word that you may or may not know is concentric circles. So concentric circles, this is an example of 2 concentric circles. They're any circles that share a center. Easy peasy, lemon squeezy, right? That's what concentric circles means. Circles that are one inside the other, they share a center, easy peasy. They don't share a radius or a diameter. Those are different, but they share a center. Last thing is circumference. You probably know this. We usually make this, I kind of made this a lowercase c, but we usually make it a capital C. So let's change that in relation to the rest of the numbers here. So circumference is 2 times pi times the radius. Now you probably know what pi is, but we're going to kind of make sure you really know what pi is. So if I was to ask you what is pi, you'd probably tell me 3.14 or 3.14159, or it's an irrational number that's blotted. You may give me a whole list of things, depending on who you are and what you've learned and all the things. So first of all, what is pi? Well, pi is a ratio. It is a ratio of a circle's circumference to its diameter. So sometimes you'll see the circumference formula written as C equals pi times D, or pi times the diameter. And that's totally a great way to describe it as well. Generally, I prefer the one with the radius, 2 pi r, one, because then it makes both of our major circle formulas, the area and the circumference, both based on radius. And actually, when we build circles, circles are built based on their radius, almost always, basically, really always, because that gives us the center. So when we draw a circle, if I was to go out to wood shop and I was to make a jig that made a circle, I would have something fixed at the radius, and then I would be moving some tool, or I would be moving the board around on some tool that was cutting out that thing. So circles are built based on their radius. So this is the formula for circles. So why is pi defined based on the diameter? Well, that's what pi is. Now, there's actually another circle constant which is based on the radius. It's called tau. It's 2 pi. Anyway, all the things. It's actually, well, I won't get into the Tau manifesto and all that nonsense here, but I wanted to note that this pi is really, really cool. Pi was discovered that pi, the ratio of a circle, any circle's ratio of its circumference to its diameter is always equal to an irrational number that's about 3.14159, etc. This is really cool. Every circle, no matter how big or how small, this ratio is always the same, always. And this is something that's not really this is something that is proven through experimentation, not necessarily through logical proof like we've learned in the majority of this class. And now with the advent of computers, we can test this with millions of different circle radiuses, radii, and discover that this is always true. Every circle always has this ratio. I think that's pretty cool. I think it's really cool. It's one of the reasons why math is cool, is because the universe is built on math. And everything in the universe can be explained ultimately with math, which is pretty cool. And that's it for this video. It's a short one. We're not going to do any examples. We'll see you in class if you're one of my students. If you're not, hope you're having a great day. Y'all have a good one. Bye-bye.